This is what my talk is about. Hey, it's what are meta-transactions and can they solve all your problems? And the answer is no. Thank you for the talk. See you tomorrow. So anyway, I hope you're listening about, if you're hearing the term meta-transactions a lot, and you're not, I hope you start listening to it, like you hearing it a lot, because meta transactions are awesome. Like I want to make them awesome, right? They sound like something boring, and they are sort of boring. It is a little bit of a technical term, but they can be very awesome because they solve like most of your problems. And what do I mean like about a meta transaction, which is cool, and a boring transaction, which is not, right? A boring transaction is one, like it's a normal Ethereum transaction, a one in which the user needs to understand gas and pay gas. Like, what is this? Like, I've been on the space for 4 years, like, and I've been helping people launch things, and everyone has the same problems, right? Everyone starts and say, why do my, like I want to launch a game, why do my users have to know what the gas is, and what do I need to, like, why do they need to buy Ether to transfer my tokens around, like they already have my tokens, why do they like, and my users are confused about private keys because they lose their private keys, or sometimes they don't lose the private keys, they just make a bunch of backups and say, oh, I've been hacked. How can you be hacked? Like, what happened? Oh no, I took my private key and I kept it on iCloud and I uploaded to Gmail and uploaded to Yahoo Mail, and it's super safe and I have no idea what could have happened, right? And it's terrible. Users are not supposed to like know these things. And then there's even the thing that you have to pay fees to move things around if you want to create a new private key. And sharing keys is a nightmare. So what can happen with meta transactions? With meta transactions, what happens is instead of your funds being kept on a private key, their private keys are just used to sign message with ephemeral private keys. Like you use one and then you throw them away. Like, and then you have a contract that verifies those messages and does something accordingly. And often that contract can be your target contract. Maybe it can be an exchange, maybe it can be a token, or maybe it can be an identity contract that is able to execute anything on the blockchain. And then anyone can deploy and pay gas. That's the magic of it. Because suddenly the private key that is signing the message is not the same that is paying for the gas. Who's paying for the gas? Anyone, really. Can be the DApp, can be like a sponsor for the DApp, can be the user themselves with another token. And because of that, the user can create as many private keys as they want and revoke as many private keys as they want. And then it's just one key per device, like, so it's safer. So let's talk about more detail on how that works, right? So first, I'm a designer, I'm not a developer, and people often think that the difference between like a design is the difference between that clock and the left clock, and it's not. Like good design is the difference between like having all those gears exposed and hiding all those gears in front of something, which obviously means that a good design needs to talk with good engineering, right? They are the same thing. It is a conversation on trying to hide complexity. So how does it work, right? It doesn't matter what you do to your crypto app, and like you can put illustrations, you can put a bunch of things. That's what I call decoration, right? You can make your crypto app really look nice, but you have to do two things every time. One of them, you have to create a key, and then you have to put money on it, right? There's no way around it. Every time your users will be there for the first time, they will have to do that. You can like put it in pink and make it a nice and make an animation. Your users will need to do that, and those steps are already inherently confusing. And what happens if they want to install in a second device, or maybe a second app that is not you, or maybe like a laptop? So they can go to the same process again, right? So they create a key and then they put money on it. Of course, it's a little bit easier because now they already have money on the other app, but now they have two keys that they have to deal with, and now they have two keys with money on it because like every time you move the money around, not only you're spending gas fees, you're always leaving a little bit of money behind. So I think that's terrible user interface, right? You don't expect that when you install Twitter on your laptop and then Twitter on your iPhone, that's going to cost you money, and then you have like little bits of Twitter tokens around. That's insane. The second thing people often do is that they just duplicate the key. And often they do it because of laziness, right? Look, I'm sorry, I'm not gonna write down a 12-word seed phrase for the third time. I'm gonna just be lazy. I'm gonna take my MetaMask seed phrase and put it here, which is super practical, but it's terrible because when you do that to a new app, you are just giving it access to all your keys for eternity. And there are even ways in which people do that, which it's not obvious that they are doing that, but they are. So for instance, often you see people who are creating a new way to log in, which is you take your username and then you use your password to encrypt it and hash it multiple times. That's also sharing your private key, right? See, even if you can create a private key out from a password and a username in a safe way, if you do that to two like different apps, you are still sharing your private key. It's a bad idea. No, don't do it. There's a third way some people are starting to do it, which is just keep the private key on a server, which can be non-custodial, right? Sometimes you can do it in a very non-custodial way, in a safe way, in a decentralized way that like the server themselves don't know your private key, but still have the same problem. It's just one private key that has funds. If that server disappears, you better have a backup of your seed phrase, and when you start that, suddenly you have the same problem that you have a private key, and then you have to share it with other apps, and then we are back to square one. So how we can make it better? With Metatransactions, right? Because they're awesome. And on the Metatransaction world, like on this magical Metatransaction world, what happens is that every device has its own key, and it's sort of okay. It's similar to what they had before, but you notice that none of them have any funds on it. So where are the funds stored? Well, the funds are stored with our super giant robot there, right? What is this, right? What we are doing is that we are creating a smart contract account, and that's the one who creates your funds, right? That who holds your funds. And all your private keys are just access tokens to them, and you can revoke them at any time. And because of it's a smart contract, you can give them limits and say, hey, maybe that server key, like you can even keep a key on the server, but maybe because it's a smart contract, you can say, look, I'm only keeping my key on the server, but I can only use my server key if I don't have access to any others, right? Which is like a cool way of doing it. So I can like give you the key and you have access to it, but you can only use your key, like the bank can only use your key-to-key recovery if you have lost all your devices, right? So the bank cannot steal your money, or like the custodial can't steal your money. And there's another thing the robot can have, ENS names, because they're awesome too, right? What is an ENS name? It means that your user doesn't need to see an hex address ever, right? They can just have like my.name.if or something similar to that. And an ENS name is just a collectible, it's just a Nifty. And so your robot can have Nifty, can have collectibles, and can have a bunch of other tokens. And I think that's awesome, right? So I think every user should have their own ENS name, and I think you should give a ENS name to everyone. If you want to send, I have a ENS name. It's pu emoji 4 times .if. You can send stuff there if you want. So, like, what's the short history of Metatransactions, right? A lot of people claim to be like the father of Metatransactions. I think the earlier example I've seen is Yuri Matias did something like back in 2016. There's even earlier examples like the Ethereum alarm clock from 2015 was already like doing things where someone makes a transaction on behalf of you. But really, it started getting a lot of steam in like last year, especially at DevCon, like sort of like the name appeared and everyone was talking about the name, and we had like roundtables, and I think a lot of people have created stuff since then. Like I can talk about a lot of examples. I would like to talk about my thing, which is universal login, right? Universal login is this idea that you can use all those steps I'm describing to make a much better login experience in which your users don't have to do anything, right? So imagine you have like 2 apps here, like Kickback and Evidence. I'm gonna start talking about Kickback. So suppose you have a browser, and let's imagine you don't have a Firefox or anything, like you don't have MetaMask or anything. So what will happen there is that you just type your username, right? I'm gonna type a username there, and then because I don't have it, I'm gonna create a username for me. So it's gonna create a smart contract, and it's gonna wait for me to send money to the smart contract for it to send it. And then we have a bunch of onboarding providers, and I think there are many people who are doing the onboarding part from crypto to like from money to crypto, and it's interesting because like each one works better in a country. So we are integrating a bunch of them, and then like for the, like ramp works perfect in Europe if you have banks. So if you're in Europe, we will pick bank, we'll pick this one, and then you can just go to your bank page, do a bunch of magic, and then you come back, and then boom, I created a, like, as soon as you send money to it, I will create a smart contract for you. I created a smart contract for you, which is that address on the top, and then you can just follow on the flow of kickback. And I think if kickback had support for three blocks, we could even skip that flow part there, because we could save all your private information directly on somewhere private, right? And kickback is a place where you can stake money in order to say you're going to an event. And the idea is like I want to RSVP to this event. I'm gonna put some money on it. If I don't go, I'm gonna lose my money. If I actually go, I get my money back, and plus all the money of the people who forfeited it. So I think it's a super interesting app because it can attract people outside the crypto sphere. But it's only going to attract the people outside the crypto sphere if you never see a MetaMask, if you never see a seed phrase or any of those, and which is exactly what you've seen. Like there was no seed phrase, there was not a mention of crypto or blockchain. You could be using kickback without even knowing what's happening behind. And here's the even coolest thing, right? Because while it was quick, you still had to go through the on-ramping and showing things to your bank and identifying, which is bad. And if you have to do it, I want you to only have to do it once. So let's suppose you want to use another Ethereum app. This is evidence. It's completely unrelated to kickback. They don't have to do deals with them. So all you do is you go into Evidence, which is an app for timestamping pictures, timestamping things, and you just type your username, right? Your username is just, and you know that you have like that ENS name we created for you, so you don't even need to remember your hex address. All you need to do now is you go back to Kickback and you approve that transaction, you approve that one. And we added this extra thing where you have little emojis, right? Those emojis are there to prevent a man-in-the-middle attack, right? Because like a relayer cannot take and change your address. You know that this guy knows that he's adding that address. And we are even doing a little game where you have to take things in place, right? This is a little just game. We know already what's the address that is being added. We are just making sure that the user realizes that this address is the same, and we are doing it with like a fun little game with little emojis. And what happens then? Like as soon as you approve here, boom, you are approved there, right? So what's going to happen is that you go on Kickback, you approve your new connection, and then you're already on Evidence. And Evidence is just like an app you take a picture and you upload it to the blockchain, and you can allow use a timestamp. So let's say maybe you are the photographer and you want to prove that you were the first to take that picture or whatever, right? So the idea, it's an interesting app that doesn't require you to understand the blockchain, doesn't require you even to have Ether in your bank account, right? Maybe they are paying your gas for some other reasons. Maybe you're seeing ads and they pay your gas, right? And that's the interesting part about this. And so we've seen like 2 apps. Let's add a third one just because it's fun. So this is Jarvis. It's like a more normal wallet. And same thing again, right? You just type your username, you choose, you're gonna go passwordless. I show you a bunch of emojis, you go on the other app, you confirm the same emojis, and just to make sure, there's another cool thing about emojis. Not only they prevent man-in-the-middle attack, they prevent a DDoS attack, because suddenly if you have like 1,000 requests, you can sort of detect which is the correct request by just picking the right emojis. And I think that's an even awesomer thing. Right, so boom, you're in, right? All you needed to do was confirm here, and you are in here. And now you can see that the balance is actually shared between both of them, right? While one is showing it in Ether, the other one is showing it on dollars. But the cool thing is that if you send money in one, it will reflect on both. Because the idea is that each app has its own private key and its own permissions, but they all share the same identity. They all have access to the same funds. They all have access to the same nifties or and etc. And and it's there, right? And here's another thing. Like in let's say 5 minutes, now you have a multisig which has 3 apps on it. So suppose you lose your laptop, right? If you lose your laptop, maybe you can still regain access to kickback by confirming on the 2 other apps that you had, right? So I've tricked the user into using a multisig without them ever understanding that a multisig is a thing, right? And I think that's super cool. But I think we can do even more, right? So this is how kickback does today, right? Kickback today, just when you click it, it has this interesting thing by Block Native, and I really like them, Block Native guys. They are doing a very good work on trying to explain to everyone what are the steps necessary for you to log in. Like, oh, you need to install MetaMask, you need to install, you have to do a MetaMask login, and then they go checkbox by checkbox. Sort of, it's cool, but we've seen that before, right? It's oh, I see you're trying to set up an Ethereum account. Can I help you, right? Those step-by-step wizards. By the way, I think we should reclaim the word wizards. We used to use that all the time, a wizard to create something. That's cool. So those step-by-step wizards, they are nice to teach users, but what is even better is just to remove that complexity so the user doesn't know to understand, right? Because really all of that, what it's doing is really this, right? It's just hey, it's a sign in with MetaMask thing where I'm teaching you what is a sign in with MetaMask. Of course, that's clearly better than this, but I mean, maybe you can do better, right? And maybe if you do universal logins, I could say, hey, what if everyone switched to universal logins? And then, yeah, but then people will still want to use MetaMask sometimes, and then we have to support both. And then if you support those, maybe there are other people who are doing those things. And then you can install, I think Pedro is doing something called Web3 Connect, which is super cool, which allows you to select which one of those 5 things you can use it. Or maybe you can use a traditional social media thing, and then you can use Wallet Connect, and that's sort of what you have to add, but it's terrible because we don't want users to be open, you open and see all those options. The user has no idea where to start. He won't start, he will probably click some button outside of that, and that's terrible. And of course you can say, hey, people tell me, don't worry about this thing, the market will just decide. And the market will just decide just means that it's a winner-take-all game, and people will lose, and there will be a single winner in the end, right? And I think that's even more problematic, right? Because this whole idea of there is a winner, and it drops. It's just universal logins and parties and Facebooks. They're just spokes on the wheel, right? This one's on top, and then that one's on top, and it spins, crushing those on the ground. And we don't want to stop the wheel, right? Stopping the wheel means putting someone on top, and they keep there on top forever. That's not what we're here for. And I think you know where I'm going, right? What we want is to break the wheel, right? And what does it mean to break the wheel in that sense, right? What we want actually is have a way in which everyone can sign in, and everyone can create a new authentication method, and everyone can create their own usernames, and it doesn't need to have a single winner takes all. And it shouldn't be a sign-in. It shouldn't be a sign-in with MetaMask or Universal Login. Maybe it should be a sign-in with Ethereum, or maybe signing with ENS names. And what I'm saying is that what it should happen is that it should be a single button that it clicks and it checks that if you already have a Web3 browser. Because if you already have a Web3 browser, boom, that's it. We've won. We don't need to do anything else. You already have a wallet. If you don't have a wallet, or if you click deny, don't want to use it, then what we need to get from you is just a username, right? And maybe you can even use a QR code at the moment, or maybe not. What I want is for you to type a username, and then I'm gonna give you an ENS address. If you don't have an ENS address, which like most of the world doesn't have an ENS address and we can change that, we want to give them ENS addresses. And every ENS address could be a different service. And I don't know, maybe the people will pick whatever they heard before, or maybe they'll pick just what sounds better, or maybe they will be informed. But what if they do have an ENS address? If they do have an ENS address, that's even cooler because you can store information on ENS address and you can query to understand what sort of authentication method you have, right? You can just go there and ask, hey, are you using universal login? Okay, cool, so I know what to do, right? And it's even better because the ENS address is also a website. And I can just say, look, if I have no idea what to do, I can just access the ENS URL. Just go to janedoe.unilogin.io, and that's where I will be requesting information, right? Maybe I have a standard query parameter that say, hey, just please add this guy to me, right? And with that, and that's how we sort of like break the wheel in a sense. Like that's how you stop the war, in the sense that I think we shouldn't be here fighting to have who has the best way to log in with Ethereum. Should it be MetaMask? Should it be universal login? No, it should be like one single thing, and that thing is a big giant robot that keeps your funds. And that is better than actually Facebook and login, etc., because that giant robot belongs to you, right? Those are your funds. That's your name. That's your ENS. And I think that is our main goal there, right? It's just make sure that everyone has control over their own profile. And that's my talk. Learn more about it on Universal Login. Follow me or check the poo 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 emoji. So I think we do have time for questions, right? So
thank you for your presentation. It was really cool idea. But have you thought about the privacy? So now all these apps know that I'm using all the other apps?
yes, we've thought about privacy, and I think like there are two layers to this, right? Ideally, like this is a blockchain privacy thing, in my opinion, right? Because in the end, right, if you want to use like I want you to use the ENS, I think everyone should, those apps should be able to know who your username is. What they shouldn't be able to know is who like how much money you have, what collectibles you have, and that is essentially a blockchain level thing. But we can really make that easier if we don't have a single private key for every user, right? We don't want to have a single private key for every user. What we want to have is the user has one identity, but it can have multiple millions of private keys attached to it. So what you could do, for instance, is that this guy could, like, what you could do is on your identity contract, you could have, let's say, you could save a root of a Merkle tree of a billion billion public keys that you own, and then you use all those keys to do things like mixing coins or owning private tokens and things like that with keys that are not attached to you. Another thing is that one of the biggest problems with privacy layer on Ethereum is always who pays the gas. So if we solve, so that's another thing you need to solve with Metatransactions, is you need to solve it that the person receiving the money is not the same that is paying the gas. Otherwise, you can just trace on who's paying the gas.
Hi, really nice presentation. Where are all those private keys kept? I mean, in the...
So I think my philosophy is that every private key should be hidden as deep as you can, depending on your API, depending on your OS, right? So if you're using a phone, keep it on the deepest memory possible. If possible, put it on a secure enclave if that has support for the key. The idea is that those keys should never leave the device, right? Like those private, or maybe if it's a browser, keep it on local storage. But the point is, never ever allow the user to see that private key. Like the user will never back up the private key or take it out anyway, right? If the user wants to do a backup, you should create a special recovery key for the backup that the user maybe prints, and that key never is online until it needed, right? So take the private key and bury it as deep as you can on the computer so that the user never needs to touch it.
Yeah. So is it possible to perform economical abstraction with this? So you can use some service that pay gas for you?
Yes, and I think that's the point, right? The point is I want you to use Ethereum and not have to pay gas in Ether. Maybe you can pay, with this system, you can already pay gas in DAI. Or maybe even you can pay gas by having a Nifty, right? Imagine that you can have a Nifty that represents membership. And whoever has that Nifty, like there is a service that will pay all the gas for that guy. And then that guy can just take that membership and move to someone else. And then that person will have like gas free. You can create all sorts of new economic models and business models on that.
Maybe one question from me. You showed this flow chart for sign-in with Ethereum, where like it would first check whether I have a Web3 provider, and then is it actually good UX if it would then just assume that if there's a Web3 provider that I would actually want to connect with that. Maybe in that case I want to connect with my mobile wallet or some other way.
A big part of Web3 provider is that the Web3 provider never shows you your ID anyway for the browser, right? That's a big part on privacy. So you need to approve the Web3 provider anyway, right? So if you're using a Web3 browser and you want to connect with it, that app should already ask you, do you want to connect with this app? And then you should be able to deny that. And if you deny that, then you can keep on the flow and connect to universal logins or whatever. Okay, well, thank you. I'll be out there. Okay, that's.
Maybe I missed it, but since you are using Metatransactions, is there a relayer who is responsible for sending those Metatransactions of all the users? Or?
Yes, Metatransactions require a relayer. You can create. You can use a decentralized relayer network. There are some you probably heard of GSN. Or you can just have the app itself can be a relayer, like the universal logins itself. We are the relayer. We provide that service so that the apps themselves don't need to worry about that. The interesting part about the relayer is that the user can always decide to use another relayer, right? The user can, if they are using our relayer by default because it's faster, but if for some reason they don't like us anymore, they can always just switch that, and that's something that is decided on the app level, right? Or maybe each app can have its own relayer, and I think that's normal.
So do you think that the whole thing is only great if all the apps will use decentralized relayer networks, or do you think that's not so important?
So I don't think it's super necessary that all dApps use the centralized relayer network, right? Just if you have, just for instance, let's say that each app uses 2 relayers, right? Or 3, maybe each app is connected to 1 or 2 or 3 relayers. That is probably already decentralized enough, because the only thing the relayer can do is prevent you from sending you the transaction, right? Because your transaction is probably has a message saying, look, I want to pay 0.01 DAI for this transaction, and whoever is the relayer that is able to do that. So the transaction itself comes with a bounty for whichever the relayer is. So if you can send it to at least 1 or 2 or 3 relayers, or if you have the option to send, or if you have the option to send a second relayer if the first relayer doesn't respond, then that's okay, right? If one relayer goes down, all you need to do is point it to someone else.
Have you thought about bringing this data availability back on the chain at all, or do you completely stick with having those signed messages purely being publicized off chain,
I'm not sure I see what would be the advantage, because if you bring that back on chain, then we start dealing with all the problems again, right? Because no one, then you have to put then you need to pay gas, then you need to have worry about storing information on chain, and that's just an information that is temporary until someone will pick up the transaction. And it's a little bit like the mempool, right? It's when you sign a transaction, it's not on chain until it's just on the P2P network of relayers until it's posted. It works exactly the same, just as this is a transaction that will go inside another transaction, right? It goes on top of another transaction. Therefore, that's why it's a meta transaction, right? It's a transaction that is talking about a transaction, and then it works in that sense. Works very similar to how it already is.